Yes, welcome to another video lesson. In this video lesson, I'll discuss a few fundamental concepts from hypothesis testing. Every problem under hypothesis testing is based on a claim, and this claim is what we refer to as a statement, which is part of the problem. This claim is analyzed as part of the hypothesis testing, and at the end of this testing, we give a decision on this claim that we are talking about. So this claim can be rephrased either using the equal to symbol, the less than or equal to symbol, or the greater than or equal to symbols. The claim is called as a null hypothesis. Its the exact opposite statement is called as the alternate hypothesis. We use the symbols H0 and HA to refer to the null and alternate hypothesis statements. On the other hand, if the claim can be rephrased, either using the less than or the greater than symbols, then the claim is called as the alternate hypothesis. Its exact opposite statement is the null hypothesis. Now, the answer to the problem on hypothesis testing is a decision on whether there is sufficient evidence to accept or reject the claim made in the question. To do this, we make use of a test statistic. Now, what is this test statistic? For any sample that is collected, the test statistic will summarize the entire collection of observations in the samples. This is used to measure the level of agreement between the sample collected and the null hypothesis. Now, how do we accept or reject? We use this test statistic and its value. The value is calculated and we see whether this value belongs to a confidence interval. The set of values for the test statistic for which the null hypothesis is accepted is what is called as the confidence interval. If the observed test statistic lies in this confidence interval, we accept the null hypothesis and reject the alternate hypothesis. On the other hand, if the test statistic falls in the critical region, that is, the region which contains a set of values for which the null hypothesis must be rejected, that is what we call as the critical region. In this case, though, we reject the null hypothesis. Now, the significance level alpha, which will be a part of every question, is the probability that the test statistic belongs to the critical region. This is what we call as the significance level or level of significance. For example, a 95% confidence interval will mean that there is a 95% chance that choosing a random sample from the population will result in a confidence interval which contains the true value being estimated. Therefore, there is a 95% probability that the null hypothesis will be accepted. As a result, there is a 5% chance, the complement of 95 being 5, there is a 5% chance that the test statistic belongs to the critical region and hence the corresponding null hypothesis must be rejected. Now, the next keyword that we'll look at is the critical value. The critical value will mark the beginning of the critical region. It's more like the boundary or the border or the cutoff point indicating the critical region. If the test statistic falls on one side of the critical value, we will accept the null hypothesis, and if it falls on the opposite side, we'll reject the null hypothesis. The next thing that we have to be very careful about is to determine whether the test that we're performing is a one-tailed test or a two-tailed test. If the alternate hypothesis involves the less than symbol or the greater than symbols, the critical region for such a test is along one of the two extremes of the sample space. Therefore, we call this as a one-tailed test because the critical region belongs to either the left or the right extremes. On the other hand, if the alternate hypothesis involves the not equal to symbol, the critical region will be along both extremes of the sample space. That is, it is present on the left end as well as the right end. Therefore, we call the test as a two-tailed test. I'll try and explain the same using an example. We're considering a large sample where we are testing the average, and the null hypothesis states that the population average is greater than or equal to 50. So the null hypothesis will denote a statement that is less than 50. The average is less than 50. And since this involves the less than symbol, the critical region is towards the left extreme of the sample space, and therefore the test is the left tail test. If the confidence interval is towards the right, the critical region is towards the left, and the critical value marks the boundary which separates the critical region and the confidence interval. Now, to give you a similar example, for a right tail test, let's consider a hypothesis statement whether alternate hypothesis is such that mu is greater than 50. So this involves a greater than symbol. Therefore, the critical region is on the right extreme and the test is a right-tailed test. Test is a right-tailed test. So the confidence interval is towards the left, the critical region is towards the right, and the line that separates the two is the line called the critical value. Now, for the same, when we have a two-tailed test, the alternate hypothesis will involve the not equal to symbol. Therefore, the critical region is on both extremes. So the confidence interval is in the middle, and both critical regions form the left and right borders. They are along the left and right borders with the critical value separating the two from the confidence interval. So this will, to sum up all that we have said, I'll just put it up under the procedure that is used to be followed for testing of a hypothesis. Step one will be to identify the sample size because based on the size of the sample, we choose certain tests over others. Step two, we look at the claim made and based on that, we define the null hypothesis, a statement which involves either the less than or equal to symbol, the greater than equal to symbol, or the equal to symbol. And the alternate hypothesis will be the exact opposite of the null hypothesis. And the next step will be to identify whether we're using the one-tailed test or a two-tailed test based on the nature of HA, the alternate hypothesis. And then we choose a test statistic depending on what the null hypothesis does to compare averages or proportions for a large sample. That is, when the sample size is at least 30 and we are comparing either averages or proportions, we use the Z test. If the sample size is less than 30 and we are still comparing averages, we use the T test. To compare variances, we use the F test. To check the goodness of fit or the independence of attributes which are part of the sample, we use the chi-square test in both cases. Step 6 will be to calculate the value of this test statistic. This calculated value we refer to as zcal, tcal, fcal, or chi-squared cal. And then we find out the corresponding critical value, the boundary that separates the critical region from the confidence interval. We call the corresponding critical values as z-tab, t-tab, f-tab, or chi-square tab. And in step 8, we compare the two and we find out where the calculated value lies in. Now, if this calculated value lies in the critical region, H0 will be rejected. If it lies in the confidence interval, H0 will be accepted. So we give a decision based on accepting or rejecting H0, and then we interpret the conclusion as the final step of the problem. So this should have given you a revision of all the fundamental concepts involved in the testing of hypothesis. I follow this with another video lesson where we look exclusively at large samples and a few examples where we compare the averages of the population and averages of the samples in the case of a large sample test. I follow this up in that video.